So you have a regression model where you want to establish the causal effects of one variable on the other. This video, I will show you how you can carry out a regression analysis using STATA. I will also show you how you can test for basic diagnostic tests such as multicollinearity, heteroscedasticity, and endogeneity in STATA. Hi, my name is Idorinoko from ID Ratios Nigeria. So you have a model where you want to establish a causal effect of one variable on the other variable, and you have chosen regression as your estimation technique. Now, at the very least, you want to use the ordinary least square regression, but the ordinary least square regression is based on some certain assumptions. One is that your residual must be normally distributed. You also have that your independent variables must be truly independent, and that is where you have the issue of multicollinearity coming in. You also have that your errors must be the same, that is homoscedastic. So this video, will not only talk about how you can estimate your model, you also carry out some basic diagnostic tests to validate your result. Let's get started. Supposing we have a topic, the effects of capital structure and profitability on firm's value. We measure firm's value using Tobin's Q. We measure capital structure using the short-term debt and long-term debt. We measure profitability using return on assets and earnings per share. So this is my model, and I want to estimate this model using the regression analysis. The B1 to B4, beta 1 to beta 4 indicates the parameter coefficients. This is my error term. The T is my time variable or time parameter, and then the I is my cross section or the companies. So I head over to STATA. I have already loaded my data sets. This is Tobin's Q, earnings per share, return on asset, long-term debts, short-term debts, and I have a total number of 16 companies across 10 years, that is from 2012 to 2021. My data has been pasted nicely in the data editor window of STATA. Now I am ready to begin. I come to the command window and I type regress. That is the command for regression. I type regress. Next, I drop my dependent variable first. So I type Tobin Q, I drop Tobin Q. Short-term debts, I drop short-term debts. I drop the long-term debts, return on assets, earnings per share, according to this model, and I hit enter, and this is my regression result. Now my regression result is divided into two parts. You have the ANOVA part, and then you have the coefficient part. The ANOVA part contains some parameters that will help me ascertain the fitness of this my model. Among them include the F statistics. You also have the R square and the adjusted R square, as well as the root mean square error. So I have 160 as the total number of observation, and this is rightly so, because if you multiply 16 companies by 10 years, you're going to have 160. The F statistics give me a value of 53.91, and it is highly significant as indicated by the probability of the F statistics. This tells me that this model is fit because the F statistics is there to diagnose the fitness of the model. If it is significant, it indicates that the model is fit, and so this result is reliable. This is also supported by the R square of 0.5818. Now the R square will tell you that the changes that occur to the dependent variable is as a result of the combined effect of all of these independent variables. So my result tells me that 58% of the changes that happens to Tobin Q is as a result of the combined effect of my capital structure proxies as well as the profitability proxies. In the case of the adjusted R square, I find that it has a value of 0.5710. This indicates that about 57% of the changes to Tobin Q is as a result of adding one more additional independent variables. So the difference between the adjusted R square and the R square is that while the R square talks about the joint effect of the independent variables on the dependent variable, the adjusted R square is referring to the additional effects of adding one more independent variable as it relates to the dependent variable. So the R square, adjusted R square, and the F statistics tells me that my model is fit, and so I can now go ahead to look at the coefficient part of my result. In the coefficient part, I find out that short-term depth has a positive and significant effect on Tobin Q. Positive because there is no negative sign here. Significant because the probability of the result is significant because it is lower than 5%, which is a commonly accepted threshold for management sciences. For long-term depth, it has a positive effect, but it is not significant because this is greater than 5%. The probability is greater than 5%. For the return on asset, I find that it is positive and it is highly significant. For the earnings per share, it is positive and it is also highly significant. So on the overall, we can see that out of the 4 variables in our model, only one appears not to be significant. All the others have the positive and significant effect on Tobin's Q. However, I want to further validate these findings by conducting basic diagnostic tests such as multicollinearity and homoscedasticity as well as the endogeneity test. In the case of multicollinearity, this occurs where the independent variables are highly correlated such that they are no longer independent anymore. There are so many estimators or there are so many techniques that one can use to diagnose the presence of multicollinearity. People use correlation, others use VIF. For the sake of this video, we are going to use the VIF, which stands for variance inflation factor. Now, the VIF will help us to diagnose if our model suffers from the issue of multicollinearity or not. So we head over to STATA and we come to the command window. The command for VIF is simply start and you type VIF and you hit enter. Now the rule of thumb is that we have two schools. Those that says that the VIF should not be above 10 and those that believe that it should not be above 5. So usually I don't allow the VIF to be above 5 because the higher the figure, the more there is a tendency for multicollinearity. In the case of my result, as we can see here, I find that return on asset is less than 5 with a value of 1.73. Earnings per share is also less than 5 with a value of 1.68. Short-term debt is also less than 5 with a value of 1.33. Long-term debt also is less than 5 with a value of 1.18. On the average, the mean VIF is also less than 5 because it has a value of 1.48. So we can conclude that there is no issue of multicollinearity in our model. Next, we want to diagnose the problem of homoscedasticity if we have met this assumption. Now, the homoscedasticity assumption involves or refers to a situation where the variances in the error terms of our cross-sectional identities are constant. That is, the errors are evenly distributed. There are a number of techniques that can help you diagnose the issue or test for the homoscedasticity assumption. One of them is the Breuch-Pagan test. And so we are going to use the Breuch-Pagan test in STATA to test if the variances in our errors are constant or not. So we head over to STATA. The command is STAT, HETTEST, STAT test. So once you type that, you click enter, and there is your result. The rule of thumb is that if the probability of the chi-square is significant, then it means that the errors are not evenly distributed, so there is no constant variance. However, if the probability of the chi-square is not significant, then it means that the errors are constant. That means there are no variances in the errors. In the case of my result, I find that the probability is significant, and so I have violated the homoscedastic assumption, which indicates that my errors are not evenly distributed. So I cannot rely on this regression result. There are a number of estimators that will help you to control for heteroscedasticity. Among them includes the weighted least square regression. We also have the robust regression. However, for the sake of this video, we are going to use the robust regression. So I come to the command window and I type RREG. That is a command for robust regression. And then I drop my dependent variable followed by my independent variables, and I hit enter. This is the result for my robust regression. Number of observation remains 160. Probability of my F statistics is also significant, so the model is fit. Coming to the coefficient part, I find out that it is only earnings per share that comes out significant compared to the OLS model. I also see that long-term debt is now negative but not significant compared to the OLS regression. On the overall, we find that it is important we test for all these diagnostic tests so that we don't make spurious interpretation of our result, because failure to test for this diagnostic test may lead to a situation where we commit a type 1 or type 2 errors in statistics. There we have it. In just few steps, you are now able to conduct a regression analysis. You are now able to estimate your model, and then you can also validate your findings in terms of the basic diagnostic tests such as the multicollinearity, the heteroscedasticity, and the endogeneity test. If this video was helpful to you, please consider to like, share, comment, and most importantly, subscribe to our channel so that next time we upload a video like this, you will be the first to be notified. Thank you so much for watching. See you in the next video.